Well, we don't have a microphone, so notice I've got the receiver unhooked. This isn't even on. So I think if I just stay in this general vicinity, the sound is all right. It's just when we get to either side of the desk and beyond, then the quality of the sound continually goes down. If I stay right here, then it's not terrible. And for this class, we pretty much have to because we're working on this. Okay. So this is just going to be a bit of a review, and for some people, you'll say, "I remember this."
I remember that.
Other people might say, "Oh boy, I'm in for it now." Okay. So, because did we do an example yesterday? Didn't we do chromium or no? We did manganese, didn't we? Well, we only got so far. Okay, so we will continue with manganese, which is element what? Okay, so that 25 is telling you that you have 25 protons or 25 positive charges. So it's going to be neutral, yes.
Can you write down the entire crossing out number thing?
The slide rule,
Uh-huh.
you didn't write it down. Anybody write it down yesterday?
You said you put it up, today.
Maybe. All right. Okay, so I'll just pause here for just a moment. Anyone else does that? I would not write this on your periodic table, and I would not put this on the back of your periodic table. Does anyone know why you might not want to do that? You're going to be doing this, and you're just going to keep flipping it over, okay? And I'm not going to go around to see what you have written, but I'm also would suggest don't do this. Okay? Make it so you can actually read it. Okay? Otherwise, it's not going to be of any use to you.
What was the little number that you wrote next to it?
Okay? So you can do this for all these, but the reason that these numbers are important is because that tells you how many columns you have in each and every block. Okay? In other words, yes, the S block has 2 columns, but you're not always going to fill that entire block up. There are 6 columns here. You might not put all 6 of them in there. Same thing with the D and certainly with that of the F. That tells you how many there is, not for sure how many you're going to put in there. We'll give you an example of that here in just a moment. Okay. I guess that doesn't quite catch the entire portion. And of course, there's going to be a glare in there, but we have no control over that. All right. So we need to get 25 of these in assorted energy levels. And if you remember, what do these big numbers mean? We said this yesterday. It can be a little more specific.
The horizontal column, the row.
Yeah, the row or the period, or maybe even more important, the energy level. That would be a good way of looking at that because the first energy level in the S block can hold how many? Okay, so what that means then is remember, we got to get all these numbers and sometimes letters to add up to 25.
Yeah.
So then we went down the first slide, go back up to the top of the next one, go back down, and then you just keep on going. Okay. So now we climb up to the top of this slide. What's the big number 2 telling you? We need a new energy level. Okay. And how many can the S block hold?
2.
Are we going to put both of them in there?
Yeah.
Yes, we are.
Yes, we are.
Okay. Yes.
P holds 6. So on the next line in the second part, you put 6 down. And you What was that? Wow.
When we say that these are short periods, which they are, these are your horizontal rows on the table. Exactly, they go like that. You always start on the far left side. Yes. For for what part though? The reason being is that this is part of the test. I mean, it doesn't tell us here, but it does say. Okay. So then we climb to the top of the next slide. Are we in a new energy level yet?
Yes.
Are we in a new energy level yet?
No.
How do you know that? We're still in the second energy level. Okay. So then, how many can that P block hold? Okay. So we're going to put all 6 of them in there. Then keep going down your slide. Okay. And how many? Okay. So then we got to go to the top of the next slide. And what energy level are we in? Okay. And what block? The P block, which is on the far right side. We're going to put all 6 of them because remember, all these numbers have to add up to 25. Okay. Then we need a new energy level. Okay. Now, this is why we would say you might not want to put all of these little numbers all the way across because we can see if we put this 10 here, and it does happen, if people are in a hurry, they're going to say, okay, we got to go back down to the third energy level, and it holds 10. What is wrong with that?
That's over.
Yeah, you have over 25 now. So you've got to remember, this is just how many columns there are, not how many electrons are in there. Okay? So, in the D block, locate where manganese is. In what column in that D block only is manganese located? 7. What column? 7. What column?
5.
Okay. Yeah. I hear 7, I hear 4, I hear 5, I hear 6.
Yeah, that's which one.
Okay. So these were the last electrons to go in. They're significant. So I just think it's always a good idea to put a box around those last set of electrons that go in there. Okay. I mean, we teach it that way when you're a freshman, and I think I just put a box around it as a habit. But now I think you do yourself a favor if you put a box around the last set of electrons every time. Okay?
Can we do a bigger one?
Sure, we'll get up to there, but you can check by saying, well, what's 4 times 2? 8.
8.
Plus 12,
And
then plus 5.
20.
So that's got to be right then. Okay? So then, oddly enough, when you look at manganese's box, what do you see there for charges? Plus 7, plus 4, plus 2, plus 3. So what that means then is pretty simple to say if it's a plus 2, well then that one disappears. That's going to be probably one of the more common ones because that's going to make it stable because this outer energy level is half full now. Okay? And especially that block. That's what we mean by that. Okay? You probably take that one and that one. So then if it was a plus 3, then I believe it would take this one and then this one. And there's various reasons why we're saying take this one, and only one of that two, this one, and maybe half of that for 3, okay? That would give us our plus 4. Because if we take this 2 out, that gives us a plus 2 charge, okay? If we take that 2 out and only one of these, that gives us what? Plus 3. If we take this one out, okay, and then half of this one, okay, although 5's not on there, is it? I think it's 4, okay? So then maybe take this one and both of those. That would give you a plus 4. And maybe it takes this one and then all of those. Excuse me, that would give you your plus 7, okay? Now, what we know happens is when we're looking at visible light and colors and why they change, it's because electrons, they can be excited and move into different energy levels, because if there's energy added to the system, this is just showing that they're rotating around in the circle, but they can certainly move up and down in different energy levels. That's why things change in color. We said if you're sitting at a fire, you throw something in there, and then that maybe, I wouldn't say makes it unstable, but you're adding energy to it. Therefore, the electrons get excited, and then it just changes color, and we perceive that color. Okay. I want to leave that up there for a moment. It's 20 after already. Okay, so you had said or requested a bigger one. Yes. Oh, yes. Okay. Otherwise, when some people are talking at the same time, then it just muffles their voice out. Okay. You said you want to do gold. Okay. So then inside of here, we've got that number. Okay. Do you want to attempt this on your own?
Yeah.
Okay. So then rather than listening to awkward silence, I would just go ahead and hit the pause button.
Okay.
We're going to go ahead and continue. Okay. So I'm not going to say anything because in my mind, I'm just following the slide rule. Okay. And if I'm wrong, then it's the voices in my head telling me the wrong thing. Okay. So. Okay, now I want to stop there for just a moment because, again, if history repeats itself, the exercise we're going to do after this is significant right here. Notice that we did it here and we did it here, and it's at this step right here. Because what fills up first? The entire third energy level, or do we jump up to the fourth and come back? We do. And if history repeats itself, people are just going to say or look in the textbook and they're going to find an electron configuration and just write what the book says. And what the author does, which I disagree with, but they continue going in just increasing numeric order. But we know that that's not correct. How do we know that that's not right? Because the slide rule tells you that. We'll come back to that in a moment. Okay. Okay, this is where I might get to be a little foggy. Okay. I think, okay.
Yep, 14 on line 4.
Okay, just a moment.
I don't think I messed up. I think
So
I
we
did right.
went 5S2, then we climb up here, and then we gotta go back and put 10 in here, okay? Then we keep on going, and then we've got 6. Now we gotta go to a new energy level again. And then we're 6S2. Now we gotta go back down to the 14th or the 4th. Put 14 in there. Now we're about ready to wrap things up. Okay? So then what column in the D block only is gold in? Okay? So then don't put a 9 here. Okay? So then here's number 9 here. It was the last set of electrons to go in. So we put a box around that.
Yep.
So this is where maybe you want your calculator. Maybe, maybe not, or just use the one that's in between your ears. That works too, right? Okay. Well, that too is just giving you your audio input. I'm surprised a bumblebee would say that. I don't know. That's just the first thing that comes to mind. See, I'm never gonna wear this shirt. I'm okay. 1, 2, 3, 4, 5, 6. 6 times 2 is 12. Okay. Then 1, 2, 3, 4. So that's 24. And we could have been putting some of these together. 10, 20, 34. And 9 is what? 43?
Yep.
7, 9. Things are looking good because that matches up. Then 4, 6, 7. And when we, 4, 6, 7. I was thinking I had to carry a 1 somewhere. So that's got to be right then. Yes. Yes, ma'am. Okay. So now, do we remember what an electron configuration was or is?
That was the C in the middle and then the Y.
Right. It's a linear depiction of what this is. Okay. So we're going to do manganese instead of gold. Okay. Because what you could do is when you're showing this in this linear depiction, is that you're saying, okay, this is our element, it's manganese, so it's 25. So then you would do 1s2, comma 2s2, okay, 2p6. Notice we're putting commas in between these energy levels.
Yeah.
Or wait, don't we do the freaking
Sigma.
There's a shortcut that you can take.
Argon, like you do that?
Okay.
Yeah.
So then
Yeah.
what we can do is I want
Use your
to
head, Tom.
erase this for just a moment. Okay. So what I want you to visualize is make a mental note of that. Now, I want you to do the configuration for argon now, which means we've got 1s2, 2s2, 2p6, 3s2, 3p6.
Mental.
What is all of those exponents added together?
Equals
18.
18. Notice that this is the exact same as what we have up here. Well, we have a little further to go. I understand that. Well, the first P block is in the second energy level, yes.
We are doomed.
Just in the P block only, yes. If I'm interpreting that correct. Now, okay, what I wanted to mention now, okay, if you remember from physical science, okay, where are the most stable elements found on this table?
On the right.
It's got a specific name.
No.
You were right, you just, noble gases, okay? So noble gases are found in column 8, okay? So what that means then is if you're dealing with any noble gas, you're gonna be in column 8. And how do we know that? Look at this third energy level, okay? You can go by the periods. It gets to be a little more tricky after you get past 3. But first period, oh, these don't match up. Okay? First period, second period, third period. Okay? So notice we went 1s2, 2s2, 2p6. What about if we stopped right there? We only had 10. That would be neon. Okay? Then we got 3s2 and then 3p in the p block only. 3p6. What happens when you add the 6 plus the 2? Gives you what? Not 18. Just, yeah, just these two. Just these two. Just these two.
8.
8. Yes. It only gives you 8. Okay? So what that means is, notice that we have equal values for these. Okay? So you do that in factoring all the time with algebra, correct? So what we want to say, all right, we're going to start with a noble gas core of 18, which is argon,
I'm gonna write this down.
which means we have all of this done already,
That's great.
because that's what argon is. Okay? So notice we've got 1s2, 2s2, 2p6. Boy, I shouldn't cross up like that. 3s2, 3p6. So we really don't have a whole lot left to go, do we? Okay, so we're up to 18, but we need 25. How many more is that? It's just 7 left, which means, according to our slide rule, right here we are at 3p6, we need 4s2, and then 3d5. 2, 5, and 18 gives you 25, so that's got to be right. Because what the author's going to do, and maybe in different textbooks, is they're going to say, oh, well, here's the configuration for manganese. You get the same answer, I understand it. Now, to me, when I look at that, that's maybe students being lazy, could be. They're not doing what they should because this one matches up with the slide rule. This one does not.
How would you
Yes.
even get that? How using it? So like, how do you know when you're at, so say you got argon down, then how do you know you start at 3?
Okay.
What I did is on the left, you do 1, 2, 3, 4 until you get to argon, and then one below that. Because it starts all over again.
Right. Okay. So to answer that question, okay. So here we are, 3s2, 3p6. Okay. So we're right here. So how do we know where to begin? Well, find where you're out on the slide rule. Okay. And then just keep going one more, 4s2, and then till you end up where you're supposed to go. We know that what makes this a little tricky is this D block begins in the 3rd energy level, not the 4th. Would it make more sense to have this as the 4D, 5D, 6D, 7D? Maybe. I don't have an answer why it doesn't do that. Rather, it goes 3D, 4D, 5D, and 6D.
Would you count for like on gold, you know, in the D block in the second row?
Okay.
Do you count the pink 57 as you want?
You've already accounted for those. The reason we know that is they're right here.
That's the F.
That's the F block.
But like, so do you, so would you,
I mean, the only way that you're going to get to the F block is if you're doing something that's as you can see, has to be an element bigger than 57. Once you get past that, okay, now you're getting down into this area of the slide rule or the table.
So like, do you count that as a box? Like, as a
Yes.
box? Okay, so count.
That's correct. Okay. Then taking the shortcut, okay, what noble gas would or should or could we use? You can use any noble gas, but if you don't choose the right one, it's just going to be a little longer of an explanation to do. But, and why can't we do radon? Because that's over 79. Okay? So if, I don't know if that works that way, of course it doesn't. Okay, if we're doing xenon, which we are, it's element 54. Okay? Well, what period is xenon in? 5p6. Okay? So that's telling us that this is full. 5p6 is full. So now we need 6s2. Okay? 4f14. Okay? And then 5d what? 5d9. And there again, we could add these together. 11 and 14 is 25. 25 plus 54 gives you what? 79. So that's got to be right. See, that's just it, because what you're thinking is, you're thinking this is 4D. It's not, it's 3D. Right. That's what's throwing you off. Okay, I think we would agree that taking this shortcut's not only just easier for me to look to see whether you're having an understanding of this. If you don't do this shortcut, okay, you can still get the right answer. It's just that you're going to be way over here and might not even be able to fit this on the board. Because notice how many different designations you would have to do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here, we're just doing 3 of them. Okay? Just this one, and that one, I believe. Yes? Okay.
So,
Okay, we're just wrapping up some questions here. We're about 5 minutes out, so we will continue next week. We'll probably have our first assignment on this, and we'll start talking about quantum numbers as well, perhaps. We'll catch up to you next time.